So this is unusual. We're a tiny bit behind, but I hope you'll forgive me. There's still going to be lunch. Now we're moving to a very, very exciting segment. And these are some of our top startups that have traveled far and are here. We're going to start with Thomas, getting Thomas up on stage, Thomas Laurent. He is, we cheated a little bit in developing our accelerator. We needed some companies that we had already worked with for a while, and we have worked with Axelos, the company that Thomas here co-founded. We have worked with them quite closely for a number of years, which is hopefully why he's going to say good things about the work that you do with MIT. But it proves sort of a point to you, I think. In thinking about new ways that we can engage industry and startups working together, you have to have some paradigm cases that you have tested this out on. And I hope that in the few minutes you have in describing your advanced simulation tools, and I think transforming engineering through advanced simulation is your topic today, Thomas.
Yes.
I hope that we get to a little bit into this bit. Your company was founded in 2000, right? Is that?
No. The technology was started in 2000, and I was actually sitting in a Professor Bertima's class.
You'll explain
at
the
the
story.
time.
Thank you, Thomas.
Yeah, but the company was founded in 2012. Well, I mean, I'd like to describe my experience in the class of Professor Bertimas. So you take the mathematical content we had here, you multiply it by 100, and you schedule it at 7:30 a.m. and that's that's what. But also extraordinarily inspiring. I think if we count the number of MIT entrepreneurs that sat in that class and were inspired, we get to 50 spin-off for Professor Bertimas on this front. Yeah, so the company here was founded in 2012, and today we are one of the STEX 25 ILP companies, meaning that we had impact with some of the ILP members, and we are recognized as an industry-ready spin-off from that sense. The mission we have with our customers is to get them to zero unplanned downtime, okay? And those are industries where downtime matters in terms of cost, in terms of producing the energy or the infrastructure we need for us as a society. So if I zoom out a little bit, this is from the World Economic Forum report in 2014, but the infrastructure demand per year over the next 20 years is estimated at $3.7 trillion. And the supply we have in terms of budget is $2.7 trillion. So you have a $1 trillion per year shortfall in infrastructure. Now we're talking about the oil you put in your cars, the electricity you use for your homes and your hospitals, the roads and the bridges, and so on. So that's important things for society. Now that shortfall, we have two ways to go after it. We can throw more money at it, and that's easier said than done, or we can use the technology we have today to optimize the assets we have. Okay? And that's where Axelos comes into play. Now, there are good news. I mean, the technology value chain that came together over the past 10 or 15 years is actually a very powerful technology value chain. The bad news is that optimizing those industrial assets is extremely complex, as Professor Bertimas could also testify. And in the case of our customers, the bad news are compounded by the fact that the assets they operate in very harsh environmental conditions. So this is a platform, semi-submersible, operating in, let's say, what it's designed to operate in. Okay, so it's extremely harsh offshore conditions. It's designed to last for 20 years. Usually today with the oil prices, what the operators tend to do is they tend to extend the life of those assets. And if you are the technical structural authority on this type of asset, you have some really tough decisions to make. Okay? If you take it in the context of the wind turbines have the same type of issues. There isn't anybody on the wind turbine, so there's no safety issue, but certainly if you have a wind turbine that goes down because of the harsh environmental conditions, the repair costs several million euros per wind turbine, and then in a wind farm, you're going to have hundreds sometimes of wind turbines. Okay? So you need to monitor what's happening, and you need to anticipate any type of maintenance defect that might be occurring on the assets. Right, so the challenge for asset-heavy industry, we know it there's a fairly fixed maintenance budget, and what you need is decide where you are going to allocate the maintenance budget. And that's not something that's easy. But the customers have been, of course, increasingly focusing on wiring everything up so that you can have smart maintenance. So what do we define as smart maintenance today? Well, we put sensors on the assets, and then we get the data from the sensors, we stream it often onshore, then we host it in the cloud, and then we apply big data analytics on those assets. And that's a good first step. We want to see that before we interact with any customers. We can't help them get there. But then once they have done this, there's a piece missing. Because once you have the sensors on the asset and you have that sensor data, the sensors will only predict 30% of your failure modes. That leaves 70% of the failure modes active or undisclosed. So you're not going to move away from scheduled maintenance to time budget maintenance, predictive maintenance, if you can only catch 30% of your failure modes. So there is a missing piece, and that missing piece can be eased if you have physics-based simulations. So if you have physics-based simulation, you can really increase the predictive power of what you're doing. The problem with physics-based simulation is they are very expensive to run. So when you run them, even on the cloud, even on clusters, high-performance computing clusters, they're going to take a lot of time to run. What we have at Axelos is really a way to run physics-based simulation, combining what people call finite element analysis with machine learning ahead of time, if you want to see it that way, and drastically increasing the speed at which you can compute the physics-based simulation, factor of 1,000, sometimes more. And what you get, if you have that, is that you can really increase the predictive power you get with sensor data. You can increase from 30%, according to General Electric, the manufacturer, you can move this to 97% predictive power. So now you can really decide how to best, what time budget you have for each asset. You can move away from scheduled maintenance to predictive maintenance, and you can optimize your assets, reduce the downtime, extend the life of the assets in a way that is lean, that is safe, and that works. So that's what we provide in a product where we have something which we call the machine DNA. So the machine DNA is this simulation you see on the left side here, and that goes into a decision support system, and then it goes into the asset maintenance dashboard, the software that the customer already have, and asset management software like IBM Maximum or some other software. So if you want to see a piece of the solution here, what you get, this is standard what you would call a finite element analysis, so except it's extremely fast. Every time you see a green bar down here, that's one of the finite element solutions being computed on the cloud. And then we aggregate all this into a holistic view of what might go wrong with the asset. So here you have the few components on the asset that might go wrong. Now you can go and snap, for example, a cable. Say you had an accident and one of the cables snapped on the asset, and then you can rerun all those simulations very fast. And of course, now your asset may be heavily damaged because you had one of the shuttle cable that has been essentially snapped. So you can see here the cage appears much more red, and you're going to have to do an inspection of that part of the asset. And this is a very simple asset compared to what we may have with some of our customers, where we model entire FPSOs in the oil and gas industry and so on. The underlying simulations is really physics-based simulation, just extremely fast. Okay? So that has been successful, and going back to Tron, we've been working with some of the larger members of the Industrial Liaison Program. We've actually modeled extremely large oil and gas assets. We've now structured a joint industry program with European funding. The company Axelos is headquartered in Europe. This joint industry program has one of the largest oil and gas operators, one of the largest certification company joining. And we're now going to augment what you just saw with sensors, and the sensors calibrating the simulation so that you can even better predict what's happening and go into defect detection early for those assets. So that's a very powerful technology that we're going to try and deploy on a very broad and wide scale to enable really world-class operational performance. Now, if I really have to summarize this, I'll go back to 2,000 years back to Archimedes and give me the right fulcrum and I should move the world. So what we have with our customers is they have made the big data investment. So they've already spent dozens of millions of dollars, sometimes more, into equipping the assets with sensors, all the big data and so on. They are aiming at the savings, at the hundreds of millions of dollars in savings that they want to get. And when we augment the predictive power with physics-based simulation, then we basically move the fulcrum so that they can leverage the investments they've already made and get more out of the Internet of Things, big data, and so on. So that's what Axelos does in a nutshell. We aim for 0 unplanned downtime, and that's it.
That's it.